Hi everybody. So we're going to talk today, we're going to do some of the, some more sample problems with the normal distribution like we were doing in class today, just to give you a little bit more of practice and heads up. So I will start by trying to figure out what's wrong with my smartboard here. There we go. All right. First example. Let's go ahead and say mu is equal to 100 and sigma is equal to 20. Okay? Can you find the probability that a random variable x is greater than or equal to, I don't know, let's say 110? Okay? The answer is yes, you can. So, of course, the first thing I'm going to do is draw a picture. So here's my picture. I'm going to put the mean here at 100. I'm interested at 110. And look at the inequality. The random variable is greater than or equal to 110, which means I need to shade the right side like that. Okay? Then I can find the calculator, and I can look at second distribution, normal CDF. My low limit, my lower bound is 110. I have no upper bound, so I'm going to use a really big number. My mean is 100. My standard deviation is 20. Click enter, and there's my answer, 0.3085. So this is equal to 0.3085. And there's problem one. All right, let's take a look at another one. I'm going to go to black here. Okay, so let's say mu is 100, sigma is equal to 5. Like that. What is the probability that x is less than or equal to 96? So let's draw the picture. We've got 100. We've got 96. Less than is to the left of 96. And so now we can look at our calculator and we can do second normal CDF. Our lower bound, we don't have one, so we're going to use a really low number. Our upper bound is 96. Our mean is 100. Our standard deviation is 5. And so the probability is 0.2119. So I'll go ahead and say that's equal to 0.2119. Okay? Now we'll get a harder one. Mu is equal to 10, sigma is equal to 7. What this says is the probability that our random variable is less than some value of x. We don't know what the value is, but some value of x. That probability is 0.74. Here's the picture. If the mean is at 10, okay, if the probability that our random variable is less than or equal to some value of x, and if that probability is 74%, it means x has to be on this side. What we're looking for is that area. In order to make that area 0.74, the x has to be to the right of the mean. So now we can look at the calculator and we can say our inverse normal asks for a left tail area, which is exactly what we have. We have a left tail area because we're shaded to the left of x. So inverse norm, 0.74, 10, and 7. And what we get is 14.5034. So x is equal to 14.5034. There's that problem. Okay? Here's another one that's a little harder. Let's say mu is equal to 20, sigma is equal to 5. The probability that some value x is less than or equal to our random variable, which is less than or equal to, say, 22, is equal to 55%. Okay, what does this say to you? Well, in our picture, what it means is this. Oops, I didn't mean 0.20. Erase that. That's 20. What it means is this. If we look at the area between some value of x and 22, we should get 55%. So this area right here should be 55%. Let me write it up here so you can see it better. There. Okay? So the problem is we got to find out what this x is. The only way we can do that is this. What we need is we need to find out this left tail area so we can pop it into the inverse normal function. Okay? Can't do the inverse normal function without that area. So here's what we can do. We can find the area of this entire region, all of this, all the way up to 22, by using the inverse normal function. So let's do inverse normal. Okay, now what is that? No, I'm sorry, I blew that. What I need to do is find the area. Should be yelling at me now. In order to find area, given the random variable values, I need to use normal CDF. Normal CDF, low number, 22, 20, and 5. 0.6554. So the red area is equal to 0.6554. All of this is equal to 0.6554. Okay? Here's the thing. All I really want is this area right here. Let's go ahead and outline that in blue. This is the area I really want. Okay? So it seems to me that if I go and I look at the whole area, the red area, 0.6554, and I subtract the black area of 0.55, I should get the blue area, what's left over. So if I subtract those two, I get 0.1054. So I know the blue area now is 0.1054, and I can use the inverse normal function to find out what x is. So I'll go to the calculator and use the inverse normal function to find that area. That was what, 0.1054. So 0.1054, mean of 20, standard deviation of 5, and it looks like this x value has to be 13.7432. So 13.7432. So x is equal to, make it black, x is equal to 13.7432. And that's how you do that problem. Okay, so tomorrow we'll do more with these types of problems, and then we're going to go ahead and add in the concepts of standardization. I did a little bit of that in period 2 today, didn't get to it in the other 2 classes. And we're also going to talk about how to find probabilities the old-fashioned way, using the tables in the back of the book. See you tomorrow.